So welcome everybody to this latest video on 162 Maths, and in this video we'll be doing another AQA topic test on the higher syllabus, this time focusing on 2D representation of 3D shapes. Now this includes isometric drawing, 3D shapes, volume, surface area, plans of elevation, and a little bit of construction. Now there will be a copy of the questions in the description below, which I strongly recommend you have an attempt at before watching this video as we go through the answers. So let's get started on this AQA topic test on 2D representations of 3D shapes. Now looking at question 1, it says here is a plan view, front elevation and side elevation of a shape that's made from centimeter cubes. Now what's important is you understand what the shape actually looks like. And what this shape looks like is going to look like something like this. Now you have been given some space to actually sketch the shape, and which hopefully by sketching or by just kind of visualizing you should have the correct answer, which is going to be 17 centimeter cubes. So let me just get a pen rather than a rubber. And so that there would be the correct answer. Moving on to question 2, it says here is a shape made from 7 centimeter cubes drawn on a centimeter isometric grid. Now on the grid below, draw the plan front elevation and side elevation of the shape. Now for the plan view, now what's important is you first label each of the views. So this is going to be the plan, this is going to be the side, and this is going to be the front elevation. So from this plan view, you're going to either have something that looks like, hopefully you're going to be using a ruler for this, but hopefully you're going to have something that looks like this, or you could have something that looks like, oh, maybe not like that, and let me just rub that shape out, or you might have something that looks like this. And either of those would be absolutely fine. It all depends on where you're standing and what your viewpoint is actually going to be. Now for the front elevation, now what's tricky is you really do need to count the number of cubes, because what it does look like is it looks something that looks like this. Now the problem with this is that if the shape did have this as a front view, you're actually going to have 8 cubes. So what it actually does look like is it looks something like that instead. And again, you should be using a ruler, which I know I'm not setting a very good example, but something along those lines would be fine. And then for the side view, that should be pretty obvious in terms of that, and the fact that you should have something that looks like this. Now one thing I would encourage you to do that isn't really allowed in exams, because obviously you need to be using black ink for your answers, is to maybe consider colouring in. I find that a lot of students tend to find that colouring in does help when they're doing the front and side view. So for example, and again, but just bear in mind that in an exam, anything that's not in black or blue won't show up when they scan your paper in. So something along those lines would be fine to help you. And then question 2b says circle the surface area of the shape, and that's going to be 30 centimeters squared. Then for question 3, it says here are 5 nets, and it says circle the letters that show the net of a cube. Now again, with this you kind of need to visualize, and basically what you kind of need to do is just a bit of practice, and you just need to visualize. I wouldn't recommend cutting it out, because obviously that people are going to look at you weird in the exam, but you kind of want to visualize and know where things fold, etc. But the correct answer you should have for this one is B and E. Then moving on to question 4, it says that a solid 5 centimeter cubed is made by using centimeter cubes. How many centimeter cubes are used to make a 5 centimeter cube? Now for this, you could count the cubes, you can sort of convert it so you can actually see the cubes, like so. And again, hopefully using a ruler. So you should have something that kind of looks like this, but definitely going to be a lot more neater than what I'm doing. And what you should have is basically 5 times 5 times 5, which gives me an answer of 125. Now moving on to 5b, it says work out the surface area of the 5 centimeter cube. Now for this, obviously the surface area is the area of all of the 6 faces. So one face is going to be 5 times 5, which is 25. And you've got 6 faces, so the surface area is going to be 6 times 25, which gives me an answer of 150. And again, working out would be 6 times 25 or something of that ilk. Then moving on to questions 4C, it says the outside of the 5 centimeter cube is painted black. How many of the small cubes will have 3 sides painted? Now going back to this, basically what this means is it's going to be the corners. And again, how many corner cubes have you got? Well, you're going to have 8 of them. So the correct answer you should have for this is going to be 8. It then says how many of the small cubes will have only one side painted. So if we go back to this, basically in terms of only one face being painted, it's going to be this one, that one, that one, that one, that one, that one, that one. And that's going to be the same on each of the 6 faces. So on each face we're going to have 6 cubes painted. So it's going to be 6 times 9, which is 54. And there is our final answer. Then moving on to question 5, it says the cross section of a prism is a right angled triangle. On the centimetre grid, draw an accurate net of the prism. Now for this, what you want to try and do is recognise the faces. So here we're going to have 5 faces. And again, this isn't really labelled. I would recommend labelling. So we've got A, we've got B, we're going to have C, and we've got this face here, which is D. Now, so from this, what you then want to do is have a starting position in terms of your net. So for this, what you want to do is, now again, we are going to need a compass for this. Let me show you how you do this accurately. So let's start off with one of the faces that's relatively quite easy. So let's start with B, and that's 2 by 4. So let's just have our 2 by 4, and notice how I'm starting in the middle with regards to this. And we've got B. Now from this, what we can then do is we can then draw our 2 triangles, and that's going to be 3 by 2. So there's 3, there's our 3, and there. Drawing those up, and again, you really do need to be using a ruler for this. And that is my 2 A's. So the next side I then need to do is my C, which is 3 by 4. So again, I've got my 4, so I just need to do my 3. Like so. And that's my C. Now the next thing I've then got to do is my D. Now for this, you are going to need a compass and ruler. Compass. Now what you need to do is with for D, what you need is to grab your compass, and you need to measure this distance here. So what I'd recommend that you do, if I just do a little sketch of a compass, and here is the pin, and here is the pencil. And what you need to do is set your pin on here and set your pencil there and measure this distance here. And let me just, so what you want to do is measure with a compass this length. Now once you've measured that length, what you then want to do is set your pin on this corner and draw an arc. Now you're probably looking at around about just over 3 rather. So in terms of the actual length, now you could use Pythagoras to work this out, but I strongly wouldn't recommend it. But you're looking over a distance of around about 3.5 pieces now. So if I put my pin on this corner, we're probably looking at doing a little sketch around there. And I do the same for here, and I do a little arc. And then from that point, what I then need to do is, we'll just get another colour, and we just need to draw our length till our arc hits that point there. Do the same from this side, draw apart, and then we just connect those up like so, and that would be our D. And there we've got our correct sort of net for this triangular prism. Then moving on to question 6, it says the diagram shows a cube and a cuboid. Max says that the volume of the cube is 429 centimeter cubed and the volume of the cuboid is 11.25. So therefore he's divided the two numbers and noted that it's 64.8. So therefore 64 cubes will fit in the cube. Explain why Max is wrong. Now there's a couple of answers in which you could write for the 1 mark. So anything along the lines of that 9 divided by 2.5 is not an integer or a whole number, so it won't fit nicely. And that probably tends to be the more common answer. You could have something along the lines of that the cuboid doesn't fit exactly against the side on the cube, so it's not a multiple and there's going to be space left over. You could also say that you can't squeeze or melt the cuboid into the cube, so you can't, obviously you're going to have some spaces in terms of that now, in terms of orientation. So again, something along those lines should get you the 1 mark. Then for question 6b, it says work out how many cuboids can fit inside the cube. Now this one's a little bit tricky because it's not quite as obvious. So if I just do a little sketch of the cuboid, of the cube rather. And let's just get the dimensions of cube. So again, we've got 2.5, we've got 3 and 1.5, and again all these units are in centimeters. So what we'll do is just see how many we can actually fit in. So if we take the orientation, now because it's a cube, it doesn't really matter what orientation we put the cuboid into the cube because all the sides are the same on the cube. So let's have a look at what we can actually maximize. So if I take it in terms of fitting it exactly in the orientation as we've got here of the cuboid, how many 2.5s fit into 9? Well, it's going to be 3. So I've got 1, 2, 3, and that's going to be there. So I've got 3 times 3 there of 2.5s. Then in terms of going up, I've got 1.5. So how many 1.5s go into 9? And that's going to be 6. And that will fit exactly. So I've got 6 going up. So 1, 2, 3, 4, 5, 6, like so. And then how many 3s? Well, that's going to be 3 3s is going to be there. So what I end up with is at this point here, let me just get rid of that, just connect those up. So at this point here, what I've got is I've got 3 times 6 times 3. So in this space, I'm going to have 3 times 3 times 3, which is 54 cuboids. So I've got 54. Now the problem is I've still got this space. Now in terms of how much space I've got here, well, 7.5 take away from 9 is 1. So I've got 1.5, so I've got 1 set here. How many 3s? So let me just write that there. So I've got 1. How many 3s go into 9? Well, that's going to be 3. And how many 1.5s go into 9? Well, that's going to be 6. So in terms of, 2.5s, and that's going to be 3. So I can actually fit another 9 boxes. So if I do 54 plus 9, which gives me an answer of 63. So it's a total of 63 boxes that will fit in. Then moving on to our last question, it says here is a cube of size x centimeters. The numerical value of the surface area and the volume is the same. Work out the value of x. So here what you will need to do is look at the volume. And the volume of this, if all the sides are x, is going to be x cubed. And the surface area, well, the area of one face is going to be x squared. And we've got 6 faces, so that's going to be 6x squared. Now, because they are the same, what I can then say is I've got 6x squared equals x cubed. And then I can just then divide both sides by x squared, because I know that x can't be 0 or a negative number, so I can divide both sides by x squared. And I end up with x equals 6, and there is my final answer. Other alternatives you could do is you could take the x cubed over to the other side to make it equal to 0. You could then factorize it. So I've got 6 minus x equals 0. And then obviously x squared can't equal 0 because we're looking at length. So 6 minus x equals 0, so x equals 6, and that gives you the same answer. But again, something along those lines would give you the full marks of 6. But as long as you're stating what the surface area is and what the volume is, you should be fine to work out what 6 is. And that concludes the end of this topic test on 2D representation of 3D shapes.